Okay, so we're looking at number 10. This is the calculator question, but I don't think we need it for number 10, that's for sure. We have a density D of an object is found by dividing the mass by the volume. Which of the following equations gives the mass in terms of density and volume? So basically, you need to solve for m in that equation. Now, those of you who are in chemistry probably have already done this a gazillion times and know the answer. But for me, it's been a while, so I need to go and translate this into algebra and then rearrange my algebra. So density is found by dividing mass by the volume. So in order to algebraically solve for mass, you would multiply by volume on both sides. So mass is density times volume, so that guy. So that was a really, comparatively speaking, that was a really easy question on the SAT. So that's the kind of question where like you want to make sure you're good to go before you walk away from it. Can't afford to get that one wrong. Okay, number 12. Oh, look, another system. Those of you who've been with us, I think this is our 4th system we've seen. Does that sound right? It's either our 3rd or 4th. There are a ton of systems on the SAT test. So your only options for solving systems primarily are graphing, substitution, and elimination. So this is a good option for substitution. So they want to know the value of x. Make sure that when you're done with this question, you're finding x. Let's go ahead and rearrange this so it just says y equals. So I'm going to multiply by 2 over here as well. So that means y equals 8. Oh man, this is an easy question. Just got to throw that into here now. So if y equals 8, then we have x minus 1. Oh, this was stupid. I did way too much work. I'll come back to the why I did too much work in a minute. This says x minus 4 equals 2, which means x equals 6. The answer is 6. I want to back up for a minute and show you something. Right here. I was going a little old school. Like math teachers always do the problems the same way because we like repetition. We like to show you guys like every single question can be solved this way. But look right here, guys. 1/2 y is the same thing as 4. So I could have gone to this equation right here, and instead of saying x minus 1/2 y, I could have just said x minus 4 equals 2. I could have been done in half the work. My bad. Oh well, live and learn. Okay, number 11. So far, some pretty easy questions to start us off today. That's nice. That's a good reprieve in the middle of the test. Remember, we talked about ordering of the test, where the first few questions should start off kind of nice, and then there should be some stinkers towards the middle and end of the test sections, but that doesn't mean you're not going to have really nice, easy ones in the middle. Like we're in the middle right now, and it's fine. So in the xy plane, the graph of which of the following equations is, ooh, vocab word from geometry, perpendicular to the graph above. So any thoughts about what perpendicular means to you, whether it's algebraically or graphically? When you say it, you're referring to what? The slope value. The slope is the coefficient of x when in slope-intercept form. So the slope is going to be the opposite reciprocal. So this line is not quite in that form. So let's do a little rearranging first. Let's add the 2x over. And then divide both sides by 3. So this line has I wrote really sloppy. This line has a slope of 2/3. But in order to be perpendicular to this, I'm looking for a slope of, and he's right, opposite reciprocal. What would that be? Opposite sign, flip the fraction, reciprocal. So I'm looking for a -3/2 slope. Now be careful, because none of these are in that nice slope-intercept form. So you either have to do a little mental rearranging, or you just have to be really aware of how you're moving terms around, or you could physically rearrange all of them. Let's see. That won't work, because that'll be a no. Methinks it's this. Right? Won't that work? If you subtract 3x and then divide it by 2, you'll get your slope. There we go. That wasn't really that bad of a question. That was a very ACT-inspired question. They like that question on the ACT a lot. I'm surprised to see it on the SAT. All right. Little vocab reminder. Remember we talked, those of you who've been with us, the geometry questions are not very frequent on this test. There's a very small amount of geometry, and it's very sporadic. So like I can't really tell you which geometry questions you guys are going to see. This is called a coordinate geometry question, and some math teachers would argue that's actually an Algebra 1 question rather than a geometry question, but potato, potato. Either way, you got to know what perpendicular meant. All right, which of the following ordered pairs satisfy the system and the inequalities above? Well, a few ways you can do this, and good old plug and chug method works great. Unfortunately, if you got a little sign dyslexia like me, plug and chug doesn't always work great because you get your signs backwards. So you can plug in the ordered pairs and test them out in each of the inequalities and see if they're true or false and eliminate them that way. But for me, I work really well when I graph things, even though my graphs are really ugly. See, I can't even draw an axis straight. So let's start by graphing this, and I'm just going to get a really ugly rough sketch because that's all I'm capable of. So my line is less than or equal to 3x plus 1. That would start at a y-intercept of 1, and it would have a slope of like up 3 over 1. That's a really ugly graph, but that's what it would kind of look like. And I knew it was a solid line, although that doesn't really matter for this question. What symbol does that say? Less than or equal to. So if I was going to shade one side of the half plane, would I be shading above the line or below the line if it's less than the line? It should be below this line, right? So I'm just going to kind of mark. I'm not ready to ruin my paper yet. Now this line, we got a bit of a problem. It is not in like graphing form that I'm used to. You can graph them in standard form. It's a little trickier. What most kids like to do is they like to rearrange it. So they're going to subtract the x over. And then they're going to divide everything by a -1 on this step. But please remind me, what happens when you divide an inequality by a negative? Doesn't something happen? Yeah, that inequality sign is going to flip. So this inequality becomes y is now going to be a less than positive x minus 1. So when I go to graph that line, I'm going to graph it in red. I'm going to start down at -1 with a slope of, oh boy, up 1 over 1, and I'm going to pretend this is a, oh geez, this is a dashed line, but I don't think it's going to matter. And I'm supposed to be graphing less than this line. Wow. If you tilt your head, it kind of looks like a line. Less than this line would be underneath it again. So your job is to figure out where they're overlapping. So it's going to be like this space over here. Now, here's a drawback to somebody who can't graph, me. I do a very good job. In hindsight, I probably should have taken the time to graph something a little better. But even with my really crappy picture, I think I can figure this out. In this green space, would the ordered pair -2, -1 be over here? And if the answer is I can't tell because your graph is so ugly, then that's my answer, and I just put a question mark next to it for now. But what about the ordered pair -1, 3? Is that in that green space? No, definitely not. Let's cross that one off. Thank you. How about 1, 5? Is that in that green space? Even with my crappy picture, maybe you can tell it's not, I hope. Oh, it's a really bad picture. How about 2, -1? I feel like that one's for sure in my green space. So what I'm going to do is I'm going to just quickly double check because I'm not willing to get this one wrong. I'm going to plug in x equals 2 and y equals -1 to both systems and make sure it works because I feel like I have enough time for that. Remember, the last 3 questions we did, even with me blabbing, took like seconds to do. They were very fast. So you can afford the time. Turns out that is the right answer. Oh, that was ugly graphing. Hey, do you guys know your graphing calculators, your fancy ones, can graph inequalities? No, but I'd like to find out more. Well, let me show you. Now, you do have to graph them in slope-intercept form, so if it's not like that one had to be rearranged, you would have to rearrange it. Yeah, get out of there. I got all sorts of weird pre-calc stuff happening, so let me get rid of stuff. Okay, so, for instance, I forgot what they were. It was 3x plus 1. And then the other one ended up being x minus 1. Well, the way you could change the equal signs to inequalities, whoops, come on, buddy, is you go back over to where like the color block is, and you can toggle between the options. For color, that's exciting. But down here for line, when you toggle between the options, what do you think that represents when it shades the upper right-hand corner? That's a greater than symbol. So we wanted less than, so that's that guy. And then I hit OK. Maybe. And then I could change it over yonder to another less than. My emulator's slow. Sorry. And I'm slow. Less than. Now one could argue this was not really a quick way to do this question. I still had to go through the effort of graphing, but if you guys, if you guys were on a test that was really important to you, That might be a really cool tool. Okay? It's better than my graph, that's for sure. Thank you, calculator. Do you guys know the calculator situation for your testing, by the way? Ideally, you have your own. That's the best scenario. So you'll walk in with your calculator. If you can borrow one from like a big sister, brother, cousin who's in college or maybe doesn't need it anymore, that'd be good. There will be approximately 15 to 20 calculators in your room, but 25 kids in your room. So it's like a fight to the death for a calculator. I don't know. So I always tell my kids to get in that room fast and tell your proctor, I need a calculator, and then make sure you get one assigned to you right away.
I think somebody's for yours.
I took a big chunk already.
You did?
I did.
The homework check?
Yes, but I don't know if it was big enough. Do you feel like you have way too much?
Yeah.
Okay. Sure. Recorded. All right, this next one. Hey, Algebra 2 students and Pre-Calc students, didn't we just do this question? Cool, let's see it again. So, a lot of words. Obviously, it's a probability question because there's a lot of words and they like to do this to us. But we have a chart of, or table of information here. 607 general surgeons and orthopedic surgeons indicated that their major professional activity, blah, 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 keep reading. It says, what is the closest probability that the selected surgeon is an orthopedic surgeon whose indicated activity is research? So I'm always worried about them doing that weird conditional probability stuff to me, and they didn't say the word given, and they didn't imply that there's a condition on my probability. So this is just straight up probability. So go to your chart and find the number of people who are both orthopedic surgeons who are in research. That would be these dudes and dudettes right there, 74. And because it's not conditional probability, you should use your complete denominator, all of the people in this chart. What's the total number? 607, yeah. So type this in your calculator, and it turns out to be that number right there. Now, I just discussed this question with my Algebra 2 kids today, so it's awesome. But I want to just point out to you guys, and not because I want to give you nightmares, I just want you to be aware of this. Very common mistake for children is that they assume they're supposed to do given conditional probability when they're not supposed to do it. So like, for instance, I'll have kids who think they're supposed to divide 74 by 230. Just because. Can you do that real quick on your calculator for me? What's 74 divided by 230? It's real close to that answer, isn't it? Close-ish. Can you divide 74 by 193? And I bet it's real close to that answer. Huh. Look at that. So this is that moment when you're on a multiple choice math test and you leave it and you think like you did awesome. You're like, I got everything. I know I did. And then you get your results back and you're like, huh, look at that. I didn't get everything. Because they're distracting you with answers that they know are common mistakes and they're going to have them sitting there waiting for you. So don't be the person who falls for their distractor answers. Those are good examples of it. Did you notice how they ordered their answers, by the way? Least to greatest? Okay. They will choose to order them sometimes to be distracting and sometimes just like this, least to greatest. So a lot of kids who say things like the first answer is never correct, or like I get a lot of things said to me that I'm like, who ever told you that? There's no 100% rule. Like I think you've all heard the C is the most common answer. I think you've heard that before. And even I've said the middle two answers are most common. But that's like not very much different from A and D. So it's not like I should have half my answers be B or C. That's not what I'm saying. But if you're flat out guessing and you have no rhyme or reason to choose A, B, C, or D, if you're just blindly guessing, yes, pick B or C. But don't like throw out A and D just because you feel like someone in your past has told you like the first and the last one can't be the right answers. That's not the case. So, has anyone heard anything weird about the test and you're curious if it was true? Nope, just nightmares? Just lots of nightmares. Okay, good. I had a nightmare about tutoring that I couldn't get here. Did I tell you guys this on Monday? I was having nightmares that I couldn't get to school. No matter what I did, I couldn't get here. I missed the bus. Why was I taking a bus? I don't know. I missed like 3 of them. I was like, oh man. I got stuck at Parker Center in my nightmare. All right, so a polling agency recently surveyed 1,000 adults. So clearly this is a survey question, and it's a lot of reading, so read carefully. And asked each adult, from a large city, asked each adult, did we do this question? Oh, we did this question in pre-calc, didn't we? Olivia, did we do this one today? Maybe my first hour did. I'm like, I just did this question. Are you satisfied with the quality of air in the city? Of those surveyed, 78% responded that they were satisfied with the quality of air in the city. Based on the results of the survey, which of the following statements must be true? I absolutely hate this question. I think I would have got it wrong if I took this test. And the only reason I got it right was because the answer was staring in front of me and I looked at their explanation, okay? I'm just going to warn you about that one right now. Now, first of all, I hate the Roman numeral questions. The 1, 2, 3, 1, 2, 1, 3, none of the above. I hate these questions with a passion. They really bother me. But anyways, here they are. Of all adults in the city, oh no, this is not the one I was thinking of. Ignore me. I do not hate this question. Take it back. 78% are satisfied with the quality of air. So I need to know your feedback on that question. Do you feel like I should keep it, I should throw it away, or you're questioning it still? So of all the adults in the city, 78% are satisfied with the quality of air. It's a quick no. Give me a reason why. Okay. Meaning you feel like you need a larger sample size in order to make that statement? Okay, I agree with that statement. And this is the issue right here. The use of the word all is like, it's like a swear word in probability land. You never use the word all, because it's all generalization and approximation, so all is a no-no. Anytime the word all shows up, throw it out. Okay, if another 1,000 adults selected at random from the city were surveyed, 78% of them would report that they were satisfied with the air quality. No, that's not how probability works. So if I go look at the next group of 1,000, the likelihood of me getting exactly 78% to say the same thing is probably not accurate, so that's a no-go. If 1,000 adults selected at random from a different city were surveyed, 78% of them would report that they were satisfied with the air quality. That's a quick no on that one either. Please tell me there's an option where it says none of them are right. Ah, very good. So the reason this was a no on this third one is because they're trying to compare apples to oranges. They're taking data from this city A and then they're trying to extrapolate that over to city B. They have nothing to do with each other. So these are all like major no-nos in probability class. You can't do any of these things. These are like the big 3 things you can't do, in fact. All right, so I lied. That wasn't the question I thought it was. Moving on. Oh, I love these. They refer to the same thing over and over again. All right, so this one's about trees. Cool. All right. Approximating the age of a tree is you multiply the diameter of the tree by a constant called the growth factor. That is fascinating. It's not fascinating. The table above gives the growth factor for 8 species of trees. Now, can you all just be annoyed for a minute? Because they're going to make you flip back and forth to look back at this chart. Can you imagine being in a high-stress testing room and like half the kids are doing this for 10 minutes? And then there's like the slow kid who like is taking forever on his test, and then y'all are done and he's doing this. Anyways, bad planning on their part. They should have just moved it all to one page. According to the information on the table, what is the approximate age of the American elm tree with a diameter of 12 inches? I don't know. But it does say here that to find it, you're going to multiply the diameter of the tree by the constant. So where are we at here? I got to read. American elm tree. There's the growth factor. So diameter times the growth factor gives you, well, that was an easy question. It's D. All right, so we're turning the page, but don't get too crazy because you got to turn back. Except not me, because I got it on my screen. That's nice. So the scatter plot. Everyone knows what a scatter plot is? That's a scatter plot. My Algebra 2 students haven't really seen much as far as scatter plots unless they've taken a stats course. It's a bunch of data points that are plotted, and if you squint, it kind of looks like a line, so kind of, sort of. But they want to know... the growth factor of the species is closely to the... Okay. Huh. The scatter plot above gives the tree diameter plotted against age for 26 trees of a single species. So this is just a whole bunch of data for the same type of tree. Go find your favorite point on the scatter plot, and it really doesn't matter where it is as long as it's easy for you to read and interpret. So like I don't know, anyone find a good one? This one looks kind of good. Like, don't you feel like, oops, not that. I feel like it's pretty stinking close to like 1290. Ish? Kind of? So here's what has to happen, guys. If we find the age of the tree by taking the diameter and multiplying it by the growth factor, well, you should be able to find the growth factor by taking the age of the tree and dividing by the diameter. So the age of this particular tree is 90, and we're dividing it by this diameter, which is approximately 12. And it's not going to be a pretty number, I don't think, but whatever. What is that? Someone type that for me. 7 point something? So now you got to go flip back to your chart and find what kind of tree is really close to that. Good news, there's only one of them. It's the shagbark hickory. It's probably not even a real tree. No, it is. I don't know. It's a really terrible name. All right, so one more of the stupid tree question. Okay, I got a lot of writing on this one. That can't be good. Okay, the white birch tree and a pin oak tree each now have a diameter of 1 foot. Now right away, why do they have to do that to me? 1 foot? Why is that a problem? It's in inches. So right away, I'm going to do a quick little, nope, 12 inches. Which of the following would be the closest to the, we talked about this a lot in the morning, and then in Algebra 2 we talked about it a lot too, guys. Anytime the word difference shows up, like circle the crud out of it, box it in, because you got to find the difference at the end of this problem, so remember that you got to find the difference of their diameters 10 years from now. What? Say what? Okay. So, either flip back or look at my screen. Let's talk about the white birch. The white birch has a growth factor of 5. So right now, it was 12 inches, right? So the diameter times 5 would be 60. Now sometimes we get lost in our problem. What did I just find? I found the age of the tree. Okay, cool. Pin oak tree. There we go. It's got a growth factor of 3. So diameter times the growth factor is 36. Cool, cool. Now it says, oh gosh. Okay, 10 years from now. So 10 years from now, how old will the white birch be? It's not a trick question, guys. How old will this tree be? It'll be 70. And then 10 years from now, this tree will be 46. Now I have to go back in the formula. It still has the same growth factor, but I got to go backwards in the formula and find the diameter. Is that what they want? The diameters. And then remember at the end, I got to find the difference between the diameters. How irritating. So a problem ago, we kind of rearranged that formula where we said the age is the diameter times the growth factor. So you guys could please solve for diameter this time. How do you find diameter? Divide by growth factor, right? All right, so real quick with this new older tree, I need you to find his diameter. So age divided by growth factor again. I'm doing this in kind of a weird cyclical way, but it's just the way my brain mapped it out when I first did this question. So for the white birch, my math is going everywhere. He's 70 years old divided by his growth factor. I think you have it right here in front of you guys if you look carefully. It's 5. So I should be able to do that in my head, but I can't, unfortunately. What is that? 14. Thank you. So this tree has a 14-inch diameter. And then this tree, which is currently 46, if I divide him by his growth factor, was it 15 something? What did I screw up now? Did I screw up? Oh, okay. 15 point what though? 3. Cool, cool. And then remember here at the end, they want the difference between the diameters. 15.3 minus 14 is 1.3. I was kind of hoping, yeah, you found a much better way, didn't you? Yeah, I know. I went like this. Whoop. Yes.
They both started at 1 foot. You could just take 10 divided by 5.
Yes, you could have. That would have been way better. Very smart. I did and undid my math twice. Did you see that? It was like growth factor divided by growth factor. That would have been way better. So this is a good lesson. Sometimes you don't do it the best way, but you get there. Time is of the essence, though, so he brings up a great point. All right. Oh, it's geometry. Hey, did you know you have a formula for this on the front of your formula page? Flip back to your formula page. Do you remember what these guys are called? So a formula page is very beginning of the test. Well, beginning of the section of the test. It's on both sections, though, so you're good. What are these triangles called? 30, 60, 90s? Yes, yes. So when you put two 30, 60, 90s together, you actually end up with an equilateral, but whatever. The pattern for a 30, 60, 90 is that the little leg, the one that's across from the 30-degree angle, is like, we call it X or S or something. So I'm going to call it X. The hypotenuse of a 30, 60, 90 is double the X. So if they want the length of AD, these are matching triangles, right? So just tell me what X is. We'll solve this, guys. If 12 is 2X, X is 6. I think we're done. That was a nice question. Now, for a lot of kids, they kind of always assume 30, 60, 90s have some weird radical thing attached to them, and we know from experience that's not the case. Oh boy, these questions are fun. The figure on the left shows a wheel with a mark on its rim, and the wheel is rolling to the ground at a constant rate, blah, 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 blah. Okay. The graph over here on the right could represent which of the following? Function of time from when the wheel began to roll. Okay, so as time progresses, would it make sense to say that that curve's representing the speed of the wheel, the distance of the wheel from the starting point, the distance of a mark on the rim from the center of the wheel, or the distance of a mark on the rim to the ground? Those of us who were here this morning, I gave a little insight into test writing. When you are writing a math question, or when you're taking a math question, let's say, if you notice there's two answers that are really horribly similar, focus on those. So like for me, my brain went, boom, right here, these two. They're referring to the mark somewhere on the edge of the wheel, comparing it to another unknown thing. So it's one of these two. Your job is to figure out which one. So does it make sense to say that this little mark to the center of the wheel, is that distance fluctuating as your wheel rolls? No, that's a constant rate. It's called radius. So it can't be C, so it must be D. Can we talk about why it's D a little further, though? The distance from this little, like pretend it's a bug, the distance of the bug to the ground is going to keep fluctuating, like getting closer to the ground, further away from the ground, closer to the ground, and it's going to keep doing that as the wheel rolls. So that was a bit of a tricky question. And I know you guys are looking at it going, oh, well, that doesn't seem too bad. The problem is when you're testing, you're very stressed out. So things that like would have seemed very easy to you, maybe don't in that moment. So you have to kind of have some tricks in your tool bag, like, oh, I'm going to look for the ones that look very similar and try to deduce between those two which ones are the right answer. Oh, this question. This is like one of those number theory questions that some kids, they look at this and they go, oh, it's very obvious. And then most humans like me look at this and go, what? So I have to really stop and think. In the equation above, A is negative and B is positive. Which of the following must be true? So you can either sit there and stare at it and think really hard, or you can just be like a normal person who would maybe just plug in some numbers. Can we just plug in some numbers? Give me your favorite negative number. Don't make it too crazy, though. -2 sounds fabulous. So pretend A is -2. And then you have a subtraction sign. Give me B to be your favorite positive number. 3. Get crazy. All right. And then we're going to divide it by, remember A? Drake came up with A. It was -2, wasn't it? Well, guys, what's happening here? You have -2 minus 3. That's -5, if I did that right. Divided by -2. What happens when you take -5 and divide it by -2? It's positive 2.5. So I just came up with an example that came out to an answer of positive 2.5. So this is not true, and that is not true, and that is not true. Because I just came up with what we used to call a counterexample to all those claims. So I think we're done. Now, there's some mathletes out there who are looking at that going, well, obviously that's the right answer, guys, because if you take a negative number and you subtract a positive number from it, you're going to have a negative numerator, and you're going to have a negative denominator, which therefore gives you a positive answer. Like, that was a lot of math theory for an SAT test, guys. Just plug in some numbers, make them your favorite, and don't make them crazy. Okay. And if you don't believe your math, plug in your next 2 favorite numbers and come up with 2 examples, and maybe you can justify it that way. Okay, this is I feel like I just did this question. It must have been in pre-calc, though. So in State X, Mr. Camp's 8th grade class, consisting of 26 students, was surveyed. 34.6% of the students reported that they had at least 2 siblings. So this is a lot of words. This would be a good moment to highlight. The average 8th grade class size is 26. If students in Mr. Camp's class are representative of the state, and there's 1,800 8th grade classes in the state, which of the following best estimates the number of 8th grade students in the state who have fewer than 2 siblings? Okay, the math teacher in me just cringed because of this. Because I'm reading that going, oh crap, half the kids are going to get this wrong. Tell me why. This is not really a hard math question. Look at that very first percentage clue they gave you about his class. Yeah. 36% students reported that they had at least 2 siblings, and they go back and they're like, I want to know how many families have fewer than 2 siblings. So for most kids, they just start pulling numbers out of math problems, and then they start throwing them in their calculator, and then I'm just taking a wild guess, but I am dead certain that if you were to use the 34.6%, one of those answers is going to be it, and it's wrong. So what you're going to need to do, if you caught that, you would quickly cross that off and you'd find the complement to that. So what would be the complement to 34.6%? That would be 65.4%? Did I do my math right? Okay. So 65.4% of families are going to have fewer than 2 siblings. So as long as you caught it somewhere in your math, you're fine. I'm just catching it right away because I'm very nervous about it. So 26 students times 65.4%, I'm just going to write it like that, equals, someone calculate that for me? So, it's a what? Did you do a decimal point here? Okay. So it's like some weird 17 decimal, 17 point something. Now remember, that's just in Mr. Camp's class. We want to know about all the classes in the whole state. So if there are, they told me somewhere here, 1,800 different classes, now you got to go back and multiply this by 1,800. And I think you get, is it C? Yeah, okay. For funsies, can someone just type 26 times 34.6, no, I'm sorry, 26 times 0.346 times 1,800? I'm guessing it's one of these. Yeah. Is it the first one? Oh, kidding me. Jerks. Now, they did rank them in order. It's not like they were trying to be super big jerks by putting it first. But it was not an accident that it showed up at all. And I think we've all had that moment in math where we're like, I killed it. And then you get it back and you're like, I did not kill it. In fact, it killed me. Okay, so, oh, look, another table. They love their tables on this test. Have you noticed? Alrighty. Townsend Realty Group. Oh boy, and it's 2 questions. Awesome. Here we go. The relationship between the monthly rental price, R, and in dollars, and the property's purchase price, P, in thousands of dollars. Now, anytime they underline something, that's them being nice, okay? They're trying to point out to you that something weird happened. So remember that the price P over here, they took off the triple zeros when they went to go write it into the equation. So that's why you're not seeing any like thousands of zeros going on. Anywho, they want to know which of the following functions represents this relationship. So essentially they want you to take these series of ordered pairs and write them into an equation. There are several ways that you can do it. Pre-calc students, you can throw some data into list 1 and list 2 and do linear regression. Remember that stuff? Nope. Well, now you will have to remember to knock off the zeros before you do it. You want to be careful about who's, obviously the R is like the Y value and the P is like the X value. So this is P, right? So this would be going into list 1, this would be going into list 2. After you enter the data, and you don't have to do all of them, you really just have to do a couple, like 2 ordered pairs, and then you'll be good. Yes?
You knock off the zeros for list 1.
Oh, thank you, in dollar, oh no, because it doesn't say in thousands for list 2. See, it says in dollars. So you don't knock off any zeros, and that's, yeah, be careful about that. So if you do list 1, list 2, you guys, because they're indicating it's linear, you only have to do 2 ordered pairs, pre-calc students, okay? Now, algebra 2 students, you know what I'm talking about. So what you're going to have to do is understand that, oops, this is X and this is Y. And what I would do is I'd find slope. This wouldn't be that hard to find slope with, right? You just pick your favorite 2 ordered pairs. I'm going to go with this ordered pair and this ordered pair because they're my first 2. And let's see, Y2, remember it's Y2 minus Y1, so 1310 minus 950 over X2 minus X1. I crossed it off, that was dumb. 176 minus 128. So after I type this in the calculator, because I'm brain dead at this point and I can't even subtract, I got a slope of 7.5. So as I look through my answer choices, there's only one line that has a slope of 7.5. Now I will warn you, I have a feeling that if you got your slope formula upside down, oh, you know what, you're in luck. It's not going to do it right. Okay, don't worry about it. I was going to say they were going to probably be gunning for you if you got your slope formula upside down, because usually they are. They didn't do it this time, so you're in luck. Okay, cool. So I didn't actually finish that question because that was the only one with the appropriate slope. Pre-calc kids, did you try to do list 1, list 2 at all? Did it work? Awesome. Okay, Townsend Realty purchased Glenview Street property and received a 40% discount off the original price with an additional 20% discount off the price for purchasing the property in cash. Which of the following best approximates the original value of the Glenview property? Okay. Glenview, where are you at? Here we go. So I don't really care about the rental price in this question, right? It has nothing to do with what they're asking about. Now guys, this is the purchase price. This is what they paid for it, $140,000. But what they're implying is that the listing price for the property was way more than $140,000. So right away, if you were stretched for time or like your brain's not working anymore or you just got stuck on this question, I'm hoping you can maybe kind of make an educated guess as to which answer works the best. Does anyone have a feeling about like leaning in one direction or the other as far as the price extremes? You're feeling C, because C is your favorite one, or you just mathematically like that number? Okay. It's actually going to be B. But let's talk about why. So they got a 40% discount. So this is like the original price. I'm going to call it X. When I take a 40% discount of that price, what would you multiply it by to knock off 40%? 60%, right? So you'd knock off 60%, or you'd multiply it by 60%, excuse me. Then this is called, like, if you just look at this as algebra, what would you call this? Like, I wrote it kind of stupid, but X times 0.6, better known as 0.6x. I know I wrote that stupid. So that's the purchase price right now. But then they got an additional discount, guys. They got another 20% knocked off. So if they get another 20% knocked off of this new price, how much do they multiply it by? 80%, right? So what's that? It's 0.48. All right, 0.48x. So a common misconception for kids is they think when you get 2 discounts like this, that this person got 60% off of their housing price, and that is not true. I don't think. Did they write it especially here? Well, we'll find out in a minute. Okay, so let's put equals $140,000 because that's what the actual purchase price was. Can you guys divide this by 0.48? And tell me what it comes out to on your calculator. 291 something something something. Yeah, okay. So this is the right answer. Do me a favor though, if we just added those discounts together, 60%, what's 140,000 divided by 0.4? What's it come out to? It came out to A. Oh, okay. So I would argue this was not a very well written question because they didn't really make it clear, especially for a child who like has no idea how a house is purchased, that you take a discount, get a new subtotal, if you will, and then take an additional discount off of that reduced rate. I feel like they didn't do a good job of making that clear. I'm curious how many kids got that question wrong. Probably a lot. Okay, so when you guys are taking discounts, think of it as multiplying by how much you are paying for as opposed to what you're not paying for. Discounts are taken away from 100%. All right. Oh, that's a lot of words. Even that makes me nervous, and I'm the teacher. I think we can get it done. All right. Psychologists set up an experiment. Cool. To study the tendency of a person to select the first item when they presented this. Okay, blah, blah, blah. In the experiment, 300 people were presented with a set of 5 pictures arranged in random order. Each person was asked to choose the most appealing picture. Of the first 150 participants, 36 chose the first picture in the set. Among the remaining 150 participants, P people chose the first picture in the set. If more than 20% of all participants chose the first picture in the set, which of the following inequalities best describes the possible values for P? Okay, so that's a lot going on in the question. So what I would like to do is kind of look at the answer choices and try to figure out where exactly do they differ. So this P less than or equal to 150, that's constant for all the choices. So that's not anything I need to worry about. So ignore that. We've got greater than, greater than, greater than, greater than. All of them have greater than symbols. So that also is not something I need to worry about. This is something I need to worry about. So here we have this 0.2 times some numbers. So in these 2 versions, which are very similar, versus these 2 versions, which are very similar, I have to figure out which ones I should be focusing on. So P is greater than 20% of 300 minus 36. So I have to ask myself, does that make any sense? Let's go back and read the question, because I kind of already forgot what the details were. It's been that long, apparently. Each person was asked to choose the most appealing picture out of 300, right? So 300 people. Of the first 150 participants, 36 of them chose the first picture in the set. Of the remaining 150 participants, P people chose the first picture in the set. And if more than 20% of all the participants. Okay. So 20% of all the participants would be 20% times 300, right? Are you okay with me saying that? So knowing that this has to be part of my formula, which groups are we focusing on? The first 2, A and B, or the second 2, C and D? The second 2. Okay, so you're gone and you're gone. So now I have to decide, is it P minus 36 or P plus 36? Which one would make the most sense here? Which of the following inequalities best describes the possible values of P? Did you notice that in both of these, P is not solved? P is not isolated. So like for instance, this one really says, if I move the 36 over, 0.2 times 300 minus 36. And this one really says P is greater than 0.2 times 300 plus 36. So tell me, which one makes more sense if P represents all of the people who selected the picture first? Would it be 20% minus 36 or 20% of them plus 36? And the key is right here. Where is it at? Of the remaining. It's this one. Because of the subtraction. That was a horrible question. Alright, here's how I actually solved this question. I took a really weird tour for it with you. It started off with, of the first 150 participants, 36 of them, so the 150 doesn't actually matter for the question. Did you guys catch on to that? When I first did this question, I kept writing it as a probability, like a fraction, and I couldn't figure out what the heck they were going for, and then I realized like 5 minutes later it wasn't a probability question. So 36 chose the first picture. And then there's this other amount, P, that they just told me it was P. And it said it was, wasn't it greater than? It was greater than 20% of all of the participants. That's all I really had to do for this question, because once I got it into that form, I should look at my choices and go, well, duh, it's D. Okay. That was a really, you ever hear of those questions in math where they give you extra information? That's what that was. All those extra pieces of stuff that seemed really pertinent to the question really had nothing to do with it. Horrible question. All right, that sticks a fork in us for the day, guys. I'm done.